So I'm probably gonna break this video into two pieces. So it's not so long. You can watch one day maybe and rewatch it the next day if you want to kind of internalize it, and then do the other video. This is the 2013 release test. So when they changed the SOLs the last time in 2009, went into effect in 2011, they waited a couple years, they finally got around to releasing a test. And so these are the problems that real students saw back in 2013. And so there'll be a few pieces that we skip because they changed the SOLs again in 2016, went into effect in 2018 or 19 or whatever it was. And so we'll go over some of these because a lot of them are very similar pieces. There's a few things we'll skip. The percents, of course, was what some other class had done. Doesn't impact us. You would have been taking this test about right now if we had stayed in session. And so this is great for us to be able to work through together as a review of all the stuff we did throughout the whole course of Algebra 1. The end of course test here that they've released for 2013. It says, look at the graph function shown. So you can see this is a parabola. And it says, based on the zeros, which best represents the graphed function? Now, I like this problem because it gives us a couple of layers of things. But the zeros are right here and may or may not be easy for you to see. But one of them is at 1 and the other one is at 3. So looking at this down here, which one of those could possibly be the function that's graphed here? And the correct answer is D. And the reason why is because if you put a 1 in there, that becomes 0. So the whole thing will become 0 because you're multiplying by 0. If you put a 3 in there, then that becomes 0. So the whole thing becomes 0. So that's why we call them zeros, and that's the function. Remember, it's x opposite sign the 0 and x opposite sign the 0. Now the 2 right here out in front is just because instead of being a normal parabola, it's steeper. We learned about that as well. And so these, if you graph them, like if you took a calculator and graphed them, this is the only one that's going to look like that in that area of the quadrant system and have that steepness. So the answer is D. 100% of those students in that class got it right. The same thing for this one. Travis would like to buy some toys to donate to charity. He plans to buy $9 at D dollars. So you can see that's $9 at D dollars, so it's 9D. That's how much money they cost. There's 9 of them. They're D dollars each. 2 toy cars at C dollars each. So we've got two cars, and they're going to cost C dollars each. And then we've got 3 train sets at T dollars each, plus 3T. So you can pretty easily see that the correct answer here was C. Now, one of the problems you have with a problem like this is reading. Not that you can't read, but a lot of times we see a problem, we're going to do that much reading, we don't really invest ourselves into that problem. So you've got to take your time, plow through, don't freak out, on a problem like that. Now, I realize we're talking about this and it's relevant to an SOL, which we may not be taking, but we're trying to learn the information because we are going to be, going on to Algebra 2. So we're trying to make sure we learn this information. And someday, you'll probably take an SAT to go off to college. These standardized tests are all in some ways similar, so that's what we're looking at. Which expression is equivalent to so on? It says assume the denominator is not equal to 0. This is just math, blah, blah, blah. It's important, it's valuable, but it's math, blah, blah, blah. We're just saying, hey, you can't divide by 0, so assume that no denominator is 0. So I'm just going to blow this up so that we can see it, or you can see it a little bit better where you're at. And we're going to reduce this. That's what they want us to do, is reduce this. And I love this word equivalent. We were in class, we really talked about that a lot. But you can see that the 18 divided by 9 is 2. That eliminates these two answers, just that by itself. Just the 18/9, like from elementary school. Because 18 divided by 9 is 2. So can't be B, can't be D. And then remember the quotient rule here is you subtract the exponent. So it's C to the 5th, and it's in the numerator because it's heavier in the numerator, so C to the 5th. And this is D to the 3rd, also in the numerator, making the correct answer A. If I go too fast, you can always back up and watch it over. Try to re-listen to my words and watch my work. It says directions. Click on a box to choose each expression you want to select. You must select all correct expressions. It says identify each expression that is a factor of this polynomial. So, wasn't a great percentage of people who got that one right. Factoring is not our favorite, particularly after we've been away from it for a while. So let's talk about factoring this polynomial. Now, we know from all the work that we did, the first thing you look for is a GCF. And when you look at this, you see, yes, there is a 2. The 2 out of that is 2x squared, 2 out of that, and the 2 out of that. So for sure, we're going to click the 2, because that is one of the factors, because you want to select all the correct expressions that are factors. So we got the 2. Now, the rest of the problem is a polynomial. Sometimes you take out your GCF, you're done. Sometimes you're not done. In this case, it would appear we're not done because none of those are that. So it must be something you could do with this further. And in fact, there is, because remember we go on to the special cases. And that's not a perfect trinomial square because that's not a square. So it's not that. And there's 3 of them. And then we come down here to part 3, which is where the leading coefficient is 1. And part 4, where the leading coefficient is not 1. And that's what we got right here. So it's the method, okay? So it's going to be a bit of a lengthy process, the method. So I'm going to talk about how we would factor that, because it is the harder one to factor. First thing we do is multiply our leading coefficient times our constant, and we get 2. Technically, we get -2, but it's 1 and 2. So we read the map, not looking for factors of 1, we're looking for factors of 2, whose difference is 1. And so here, would it be 1 minus 2 or 2 minus 1 to give us the -x? And of course, it would be the 1 minus 2. So what we do, and I'm just going to leave the 2 there. I've already taken care of it. I'm only working with what's in the parentheses now. So I'm going to keep my first and last term. Thought I did that in color. I'm going to keep my first and last term. And I'm going to turn that middle piece into 1 and 2. So it's going to be plus x minus 2x. I could have put the minus 2x first, but whichever, right? So I've done that because of the 1 minus 2, factors of 2's difference is 1, and I got to get it to be a negative x, so 1 minus 2 is -1. And then I group my first group, my second group. The GCF of the first group is x, so I get, take the x out, I get 2x, take the x out, I get 1. And here there is no greatest common factor except 1. So I'm going to take out a 1, put middle sign in the middle, which is nice because in the -2x divided by the -1 is positive 2x, and the -1 divided by -1 is positive 1. So the beautiful thing happens. So you can see I got the beautiful thing, which is 2x plus 1, so I need to click that. And then I got the x minus 1, so I need to click that. Right? Square root of 18 in simplest radical form. Square root of 18. If you put that in a calculator, it comes out to be 4 point blah, blah, blah. Because it come out cubes, not a cube square, like 9's a square, 16's a square, so on. Square root of 18, 18 is not a square. But what we're supposed to have learned, and we talked about it a little bit, the square bar and some of those things that we did, is that 18 is 9 times 2. It's also 3 times 6, but neither one of those are squares. But 9 times 2 is cute because that's a square. In fact, that's the square hiding in there. And so the square root of 9 is 3, and the square root of 2 is the square root of 2, making the correct answer B. Which binomial is a factor? And this is what they do with a lot of these standardized tests. If they gave you both factors, you could easily like do the FOIL, see who comes out to be that or whatever. But by giving you only one factor, it put a little more pressure on you to actually know how to factor. There are ways around that, to be honest, but you know that's the way this is going to work. So we have this trinomial. There's no GCF. We can look and see. Special case would be a perfect trinomial square. That's a square. That's not a square. So we end up realizing that the leading coefficients, one is the easy kind, so it's going to be double bubble, C and C. Signs are the same. They're both negative. Factors of 32. So 1 and 32, 2 and 16, 3 does not work, 4 and 8. So when I read the map, factors of 32, whose sum is 12, will be 4 and 8. And then you've got both of the factors here. Which one of the factors is over there? The C minus 8. What is the value of this expression when x is 2/3? What they really want us to do is, like if this is f of x, this function, they want us to find f of 2/3. In other words, everywhere you see an x, you put in a 2/3, which is kind of tough because it's 2/3 squared plus 3 times 2/3 minus 2. Run out of room there. And so we have to do that, which is 4/9, because 2 squared and 3 squared. And do that. If you do 3 times 2/3, you actually get 2 minus 2. The minus 2 in the end. And the 2 minus 2 cancel, and I get 4/9. Now, if you had your calculator, you could actually plug all that stuff in the calculator and not have to do the math for it. Push the button, ta-da. Just put them in as fractions if you've got the TI equipment. And it comes out really, really nice. Which expression is equivalent to that? Well, that's a really good question, a really good problem. There's a couple of ways that we could approach this. One is to work inside the parentheses, which means this negative is going to push the x into the denominator. So we have 3 to the x to the positive 4. Y'all remember how to do that? That's the way it would work. And then this would be 5 divided by x to the second, the positive 2. Because when you have negative exponent in the numerator, you put it in the denominator, make it a positive exponent. Same thing here. Now we've got a square here, so we work in parentheses first. It's PEMDAS, parentheses, exponents. We've got to do that. What is 3 squared? 9. What is x to the 4 squared? That's a power raised to a power, which is x to the 8th times this one. It didn't have a power out here other than 1, so it's of no real significance or consequence. So you can see the numerator is 45, and the denominator, what do? This is the product rule because we're multiplying here. You know, that's quotient, but this is a product rule because we're multiplying. And so in order to do the exponents, we add them, making the correct answer C. Which polynomial is equivalent to that one? We just did division, you know, not too long ago. And we know we could do long division. We could, but we're not going to in this case. Maybe we should, but we're not going to in this case. I'm just going to point out to you that you can factor that numerator. Now, if you factor that numerator, you're going to have to do the method because the leading coefficient is not 1. So let me just set over to the side a little bit and talk about this. Is there a GCF? No. Is it a special case? Well, if it is a special case, what special case would it be? It would be a trinomial, perfect square trinomial. Well, that's not a square, so that's not the case. So it ends up being the method, okay, the method. And in the method, you do the 1 times the 18, you get 18, the factors of 18 are 1 and 18, 2 and 9, 3 and 6, and when you read them out, factors of 18 whose sum is 9. So you're going to keep the first term and the last term and turn the 9 into 3 and 6. It's a minus 3n. Oops. That's a minus, please. Minus 6n. So it's a negative 9n in the middle. Nothing changed. The first term's still the same. The middle term's still the same, just split up. And the last term's still the same. So we do our grouping, because you got 4 terms now. The GCF of the first group is 3n. Right? 3n. Take the 3 out. Take the n out. What's a negative 3n divided by positive 3n? So that's a minus 1. GCF here, it's 1. So we're going to take out a 1. But we're going to take out a negative sign, middle sign in the middle. So that makes that a positive 6n. And positive 1 divided by negative 1 makes that a negative. So you can see what we end up with right here is 3n minus 1 and 6n minus 1. The 6n minus 1 is the beautiful thing. The 3n minus 1 is the GCFs. And so what happens here? These two cancel, leaves me with 6n minus 1, which is answer A. Type your answer in the box. The technology enhanced questions are always tougher. You can see that class got none. Nobody got it right. But they're always tougher because you don't have the multiple choice, you can't guess, you can't really work backwards, and there's just, you're just kind of stuck. You gotta either know what you're doing or know what you're doing. So they're always just a little harder for us to deal with, and they're doing more of those in standardized testing in general. It says type your answer in a box, so they give you a box. What is the value of the expression when A is 64 and B is negative 5? Now I will say this, when they give you something like this, you've been doing formulas since 5th grade, plugging in values for length and width to find area and volume, and you've been using formulas a long time. So plugging in values is not a big deal. So let me take this original problem, that's the cube root of A plus B squared. Let's take that original problem and let's plug in the pieces where they go. So that's a negative 2, it's the cube root of 64, right? A is 64. Plus B squared. Now I'm going to put the B in parentheses because I'm going to square the negative 5. And I can tell you that's where you're going to miss it. Because we talked about how that negative 2 squared is not the same as the opposite of 2 squared. If you had your super duper high power calculator, you'd find out that's a positive 4 and you'd find out that's a negative 4, and those things are definitely not equal. So that's really going to trick you because you're not paying attention to those little details. We're squaring whatever B is. What is B? It's a negative 5. So what is a negative 5 squared? What's a negative 5 times itself? 25, a positive 25, and that's where most people are going to miss this question. The cube root of 64 is 4, because 4 times 4 is 16, times another 4 is 64. Maybe a little harder for you to do if you had a calculator, it wouldn't be, but the cube root of 64 is 4. You put that with the negative 2, makes negative 8 because you're multiplying here, and so that ends up being negative 18 plus 25, 17. Would be the correct answer to put in the box. It says when n is greater than 0, and the only reason they say that is because you can't be taking the square root of a negative thing. Okay, if n was smaller than 0, it'd be taking the square root of a negative thing. You can't do that in the real world. You do it in algebra 2 in imaginaries, but you can't do it here. So which one of these is equivalent to that? So we got the square root of 42 n to the 9th. Now, you think about it, you can't do the square root of 42. You can't do the square root of 42, it's not a square. And when you think about a 42 and its factors, 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5 doesn't work, 6 and 7. And the only one of those that's a square is the 1, so you can't simplify the square root of 42 at all. There's no square hiding in there. There's just not. So the 42 is going to stay in the house, which means it's got to be one of these two here. It has to be one of those two. Now, the square root of the end of the ninth, I want to talk about that for a second, because end of the ninth is end of the eighth times n. Why does that matter? Well, that is right? It's end of the ninth. Why does that matter? Because that is a square. Because when you do the square root of the end of the eighth, you get into the fourth. And then you got the 42n left in the house, and so that's the answer, B. Look at the system of equations. What is the value of x? Again, if they gave us the x and the y, we could plug them both in and check. Like, you don't even have to know how to do it, just have to know how to check it. And so we see a lot of this where they're giving us one value, not the other, one binomial factor, not both. And so they're forcing us to have some insight into how to do work, how to actually solve the problem. There are three ways that we talked about doing these problems. One was by graphing and see where the two lines meet, because those are linear. Where the two lines meet, week at the beach. We talked about elimination, which is a very algebraic process, beautiful algebraic process, and substitution. We also said that some problems are built for graphing. If they're already in y-equal form, both of them, one of them is here, if they're already in y-equal form, great, we just go. If they're in some other form, sometimes elimination is our best option, sometimes substitution is our best option. In this case, I believe substitution is the best option because we can take what y is and put it where y is. So when we do that, we have the 7x plus 4 times what y is equal -1. Do you see what I'm saying? Y is that. If y is that, then you can put that what y is where y is. And now, how many different variables do you have? Just one. It's just x. The y is gone. So that's substitution. We don't have the y to deal with anymore in this problem. So we've got a little work to do, though, because we've got to distribute the 4. Distribute the 4. Be careful with that. Be real careful with that. And then these are like terms. So that's 3x. I'm going to go ahead and throw the 8 across. Be a subtract 8. Makes that a -9. And so x is -3. Now, if I was doing this on a real test, a real SOL test or a real standardized test, I wouldn't stop there and go, oh yeah, my answer's there, because it is, it's there. I'd want to know for sure. Like, I'd want to check. I'd want to go a little further, a little deeper into the process. And they could ask us for both, the x and the y. But if I already know the x, then this would be a really good way for me to find the y, because I just plug in my -3 here. What is the opposite of -3? Or a negative -3? It's +3. So y is equal to 5. So I think my answer is -3, 5. My ordered pair answer, the point at the beach. And then I could check that in both equations to be sure. But -3 is the answer that I'm looking for here, not 5. Because you can see that's there too. That's the y value they asked us for, the x value. Be careful, be careful, be careful. Pierre solved an inequality as shown. So you got Pierre's work. One of the things that I've noticed in standardized testing, and in your Algebra 1, if you'd had an SOL, you would have been able to go back, and it's not computer adaptive, so you've been able to go back and rework a problem or check an answer or skip it and come back to it. But one of the things that I've noticed is a lot of times you'll get a hint in one problem for another problem. So let's look at what is going on here. And they want to know about properties. We're not great at properties. It's not our most favorite thing, but it is. It's which property justifies the work between steps 3 and 4. So when I look at step 3 and step 4, the big question is, what changed? Because that's going to kind of give me an understanding of property. What changed? Well, the left side didn't change. The inequality sign didn't change. The only thing that changed is I went from having an n plus 0 to just an n. So is that the inverse property? Is that the identity property? Is that the addition property of inequality, or is it the commutative property? Well, hopefully you realize it's the identity property, because you take a number and you add 0, you get the number. Yay. And which property of real numbers justifies the work shown? So it's another property problem. Again, what changed? Left side, nothing. Right side, look at it real careful, because they're going to try to trick you here into thinking this is the associative property because it's got parentheses. So they're going to try to get you to think it's associative. But look, the association did not change. The 12x is still associated with the 15. It did not change. What changed was the order of the 12x plus 15 into 7. That's what changed. So they moved. That's the commutative property. Careful with those. Remember, their favorite ones are distributive property and transitive property, but that's not been the answer in either one of these we've done. What is the slope? Ooh. A lot of people's going to say, oh, it's the coefficient of the x, it's 1/8, yay. No, not yay. Because that's not in the right form. What's our right form? Our right form is our new best friend forever, which is the slope-intercept form, which that's the slope. Is that in that form? No. It doesn't say y equal. It's got everything but y equal. So we're going to need to work with that a little bit. I'm going to copy the problem. And I'm going to know that I've got to get y by itself. Now, if I could make the fraction disappear in the equation because it's an equation of fraction, but probably what I'm going to do is, I might should have done that actually. I'm going to subtract 1/8 x on both sides. Then I'm going to divide by 3. Divide by 3, divide by 3, divide by 3. That's easy. Negative 1/8 divided by 3, for some people, that's a mind blower. Negative 1/8 divided by 3, which is a negative 1/8 times 1/3. Because remember, we don't divide fractions, we multiply by reciprocals. Get Kentucky Fried Chicken stuff, Kentucky Chicken Fried. And so that ends up being a negative 1/24. So what's the slope? Now that we have it in this form, what's the obvious slope? Negative 1/24 b. Now, I'm compelled here to go back and take the problem from here and work it a little bit differently. Because I said this is an equation with fractions, and we could make the fractions disappear. How multiply by the least common denominator? What is the only denominator here? 8. So everybody's going to get multiplied by 8. So that multiplied by 8 is x. That multiplied by 8 is 24y. And that multiplied by 8 is 24. So now I've still got to solve for y. So I'm still going to kick my x over to the other side. It'd be a minus, right? Subtract from both sides. And then I'm going to divide by 24. Divide by 24, divide by 24, and divide by 24. Same answer, different process. Go back and watch that again. See which one works for you. Get it in your mind, internalize it, because you're going to see this stuff again. You just are. That's my little slide so that we can talk about how math is in our world. Everywhere. I can guarantee you these things were not done without lots and lots of mathematics. Making people safe, you know, being able to do the centrifugal forces and so on and so on. Tons of math goes into that, engineering. So it's typing inequality in the box. Another one of those technology enhanced questions where you just have to put something in here. It says use these symbols, which are going to be available to you on your keyboard for the inequality sign. They did not put the equal ones because they're harder to find on the keyboard. So you just got that. They want you to solve this. So it's a negative 2x plus 6 is less than x minus 6. Now this should be pretty easy, but they've got that one little thing that I thought of a while ago, that when we did that other problem, I said sometimes you see something in one problem that reminds you of something that you might use in another problem. If I'm going to do this problem, I'm going to get all my letters on one side, variables, and all my numbers on the other side constants. And so I'm gonna probably kick that over there, make that a negative 3x, and I'm gonna kick that over there and make it a negative 12. Do you agree with subtracting x and subtracting 6? Then I realize if I want to get x by itself, I've got to divide by 3. Actually, I got to divide by negative 3. And if I divide by negative, I have to remember to flip the sign, and that's where most people are going to miss this question. It's really an easy question except for that one thing that I got to remember. So I'll divide by negative 3, I get an x. I divide by negative 3, I get a positive 4, and that's what I actually would write in the box using inequality sign. Which graph best models this? Remember when we had these, the first thing we did was build a fence. Build the fence. The fence occurs at the equal place. So it's a positive slope, but all of those are. The y-intercept's at negative 2. That one is not, so he can't be the answer. That one is, he might be the answer. That one is, he might be the answer. That one does not have a y-intercept at negative 2, so he's not the answer. So I'm down to those two. Those two actually have the same line, they just have different shading. So remember what we did after we built the fence, and by the way, it's a solid line because it does include the equal, so it does include the fence, so it's solid, not dotted. And so we have to decide where to shade. And so we're going to do a test point. And either the test point works or it doesn't. And if it works, then that's where we should have shaded. And if it doesn't work, then it's the other people on the other side of the fence who do all the work. And that's where we should have shaded. So I'm going to try 0, 0 in my original problem. So I'm going to do my test point for 0, 0. Doesn't have to be 0, 0. I just like that one. If I can use it, I usually do. So I've got my original problem. I put 0 in for y. That's why I like to do those, because you can't get the x and y backwards. And I put 0 in for x. And 2 sevenths times 0. And so I end up with 0. It's a pitiful looking 0. 0 is less than or equal to negative 2. That's just not true. It's just not true. So that doesn't work. So I should shade on the other side of the line, which means this is the one that's right. See, this says that 0, 0 works, and it does not. It says 0, 0 works, so all of its friends work, and it does not. It did not work. So because 0 is not less than a negative 2. It's just not. Yeah. Okay. Which inequality represents all the solutions of this? So I think this is the last problem I'm going to do in this video, and then we'll have the rest of this material in a second video. It says which inequality represents all the solutions for this. So it's like the problem a couple of problems ago where we have an inequality. This one's a little different, a little more complicated in some ways because you got distributive property a couple of times, but we're not allergic to the distributive property, so that's 36x. Distribute, that's minus 72. Distribute, that's 24x. That's 36. Hopefully that's easy. Then, I lost my little tag on my 4. All right, so 24. So I'll throw the 24x over here, makes that 12x because I'm subtracting. And then throw the 72 over here, which makes it plus 72, which I believe is 108. So x ends up being, if I divide by 12, less than 9. So that would indicate the C answer. And I had no reason to flip my sign because I didn't multiply nor divide by negative.